In the previous sections, we talked about two types of composite values, tuples and records. One of their typical features is the static size, meaning we must determine the number of their components when creating them. However, sometimes we just cannot predict the amount of data we will be working with in our program. And that's why we need a different composite value which can be defined dynamically. For these situations, Reason provides us with arrays whose size is dynamically computed. And we will talk about arrays in this section. Let's take a look at how to create an array. There are two ways to do that. We can define our array statically or dynamically. We will use static definition when we know the elements and the size of our array in advance, meaning at compile time. However, when we don't know the size of our array in advance, we need to compute it dynamically first. Let's say we know the structure of our array, so let's define it statically. We created an array with 3 elements. These elements are separated by commas, and the whole array is encapsulated inside the special type of brackets, which are composed of a square bracket and of a pipe. Arrays are fixed size at creation time, meaning when we define array, we cannot change its size later. They are also mutable, and we will talk about it in one of the upcoming sections. As you can see here, the compiler inferred the type of our expression, and it's telling us we have an array of strings. We can also write the same code by defining a type identifier first. We defined the person type identifier, which is an array of strings. Then we used our type to constrain the type of the Han identifier. As a result, our array has type of person, which is an array of strings. In this example, we declared the type of our array in advance here. Compared to tuples and records, we are not specifying the number of array's elements. We are just saying that our array will contain an unspecified number of strings. And that's a good thing, because otherwise we wouldn't be able to define our arrays dynamically. We also need to keep in mind that in exchange for this dynamic definition, all the elements of an array must have the same type. This means we should avoid mixing values of different types in a single array. Here, we defined an array containing integers and a string, and we got a type error since we mixed different types in a single array. And this is different compared to tuples and records, where components can have distinct types. So, we know how to define arrays statically. Let's take a look at how to create them dynamically. We defined a function createArray, which can be used to initialize an array dynamically. Our function expects two arguments, length and field name, and it will pass these arguments to the built-in function array.make, which will return an array of the particular length. You might notice that the compiler inferred the type of our function. It's telling us that our function expects an integer and alpha type, and alpha refers to a polymorphic type, meaning it can be a value of any type. The array module in the standard library provides us with many different built-in functions we can use on arrays. And array.make function we've just used is one of them. There are other functions we can use to create an array dynamically, such as array.init, or we can use array.length to get the size of an array. Let's now create an array dynamically by calling our function. We passed an integer 5 as the length of the array and a string called field, which will give names to our elements. And we got back dynamically created array containing 5 elements of type string having the name of field. And that was a dynamic array creation. Now, let's take a look at how to access elements of an array. First, we will be accessing only a single element. We created an identifier Han containing an array. Then we defined a function that expects an array and returns its second element. Then we passed our array to it here and we got back the second element solo. To extract a specific element of an array, we are using an index. An index is an integer that represents a position of an element in the array. Keep in mind that array indices start at 0. To access an element, we first write an expression representing an array here. Then an open square bracket, then an expression representing an index, and finally a closing bracket. So, we know how to access a single element of an array. Now, let's take a look at how to extract several of them. To extract several elements of an array, we can use pattern matching, or in other words, the structuring. Pattern matching arrays is similar to matching tuples. Let's try to extract values of our array using pattern matching. We again created an identifier Han containing an array. Then we extracted 3 elements of this array using pattern matching here. Finally, we checked if our pattern matching worked. The compiler accepted our pattern matching. However, it gave us a warning, and it's telling us that our pattern matching is not exhaustive. This means we are not covering all the possible scenarios that might happen. The compiler is explicitly telling us that an empty array is not matched by our pattern. For now, we can ignore these warnings because we are working with fixed data. As you can see, we are using lead binding for the pattern matching. The pattern that matches an array is defined the same way as an array, meaning it's composed of subpatterns separated by commas. Here, we specify the pattern that we use to extract these three elements of our array: first name, last name, and occupation. And it worked, as you can see here. We can also perform pattern matching using a function. We defined a function that takes an array with three elements as an argument and returns two of them. We are using array patterns to extract the first name, last name, and occupation fields from the passed array. So when we called our function by passing it an array, we got back an array containing first name and last name. Maybe you were wondering, why are we matching three elements when our function returns only two of them? We are matching the occupation element, which we are not using. So why are we doing that? Well, let's try to match only the first name and last name elements in our function. We still have our array here, and we modified our function so it extracts only two elements, first name and last name. Then we passed our array as an argument to the function. And our function crashed since we passed an array with more elements than our pattern expected. We need to keep in mind that the number of subpatterns must be equal to the number of array's elements we are pattern matching. In this example, the pattern expected an array of two elements, and we passed an array of three. As you can see, we need to be extra careful when using these array patterns. This is also true when accessing elements using indices. We defined an array of 4 integers, and we tried to access its fifth element using an index number 4. And our program crashed since we tried to access an element which doesn't exist, since the length of an array is its length minus 1. This error cannot be caught by the compiler, since it cannot predict if the expression that we are using as an index will eventually evaluate into a valid index of the array or not.